Alright, in this video we're going to go over L'Hopital's rule. Alright, L'Hopital's rule. If you have a limit come out to an undefined result, and remember your undefined results are results such as 0 over 0, infinity over infinity, 0 raised to the 0 power, infinity times 0, and so on. Alright, if you get an undefined answer, result, what you need to do is take the derivative of the numerator and denominator separately. Don't do quotient rule. Just take the derivative of the top over the derivative of the bottom and try plugging in again. Alright, so let's look at the example. We want the limit of x squared minus 4 over x plus 2 as x approaches negative 2. If we did the normal method, I'm going to do the normal method first, and then I'm going to show you L'Hopital's rule. Right, the normal method, we would get 0 over 0, so we couldn't do that. This is 0, not a 6. So what we would normally do is factor the top, because the top is factorable. So we'd get x minus 2, x plus 2, over x plus 2 would cancel this out. We get x minus 2. Now we'd use direct substitution to get negative 4. Alright, now this graph would not actually have a vertical asymptote. What this graph would look like is it'd look like the graph of x minus 2, and then at x minus 4 we'd have an open hole. Alright, so at x minus 4 we have an open hole. So this doesn't actually have a vertical asymptote. Now, because sometimes factoring these can be a little tricky, alright, here's how you do it with L'Hopital's rule. Alright, the limit of x squared minus 4 over x plus 2. Alright, remember, since this gives us an undefined result, 0 over 0, the first thing we're going to do is take the derivative of the top. The derivative of x squared minus 4 is simply 2x. The derivative of x plus 2 is simply 1. So that's 2x, and we want, as x approaches negative 2, direct substitute that in to get negative 4. As you can see, they both give us the same exact answer. Alright, now let me show you another example where this comes in even more handy. Alright, let's do the limit of x squared plus 3x plus 2 over x squared plus 6x plus 5. Alright, if we as x approaches negative 1, if we plug in negative 1, and you can do this yourself if you want, we do in fact get 0 over 0, which we can't have. So now what we want to do is take the derivative of the top and the derivative of the bottom separately. So this would be 2x plus 3 over 2x plus 6. Now you want to plug in the negative 1. Alright, so give us negative 2 plus 3 over negative 2 plus 6, which negative 2 plus 3 is 1. Negative 2 plus 6 is 4. Alright, so the limit of this as x approaches negative 1 is 1/4. Alright, it is 1/4. Now, I'm going to leave these up here, and I'm going to give you one to try. Alright, so here's your you try. Find the limit of 2x squared plus 3 over 3x squared minus 4 as x approaches infinity. So pause the video, take a few moments and figure this out. Alright, so as x approaches infinity, if you plug this in, of course you get infinity over infinity, which doesn't really tell us anything. So take the derivative of the top, which is 4x, the derivative of the bottom, which is 6x, and oh, look at there, the x's cancel out, leaving you 4 over 6. You can pull a 2 out of the top and bottom to give you 2/3 as your derivative. If you remember the old way, if you remember the plus 3 and the minus 4 really don't mean much, those cancel out, so you get 2/3. Alright, so L'Hopital's way we get 2/3, and the old way we get 2/3. Alright, so this is a short video. Alright, but there is one more thing I want to say, but then this is the last thing I want to say. Alright, make sure you write this down. The limit of f of x must be positive or negative infinity for a vertical asymptote to exist. Alright, and this is the limit as x approaches c. Alright, so the limit of f of x as x approaches c must be positive or negative infinity for a vertical asymptote to exist. Alright, like I said, this is going to be a shorter video. That's really all the information I wanted to give you in this. I just wanted to go over L'Hopital's rule with you. So make sure you watch this video and understand how to do what L'Hopital's rule is and how to do it. Alright, see you tomorrow.